So now let's discuss the third case. Now let's discuss the third case, that is multiplication. Okay, multiplication. Yes, here you are given two physical quantities A and B, and the resultant Z is equal to A into B. In the previous two cases, the resultant Z was equal to A plus B, and it was again equal to A minus B. Now the resultant Z is equal to A into B. Here we are considering, or here we are going to find how errors get combined. How errors get combined when we multiply two physical quantities. Yes. So when I measured the value of A, I got the value as A plus del A. A plus del A. When I measured the value of B, I got the value as B plus or minus del B. Is it clear? Yes. So we know Z is equal to the value of A into the value of physical quantity A into the measurement value or measurement, whatever it may be, the measurement of A, the measurement of the physical quantity A multiplied by the measurement of physical quantity B. So we can say Z is equal to A plus or minus del A into B plus or minus del B. Yes, just like in the previous cases, since there is some error in the measurements since there is some error in these given measurements, obviously some error will arise in the resultant also. So we can say Z plus or minus del Z. Z plus or minus del Z. Here we have to find the maximum possible value. Here we have to find the maximum possible value of del Z. Maximum possible value of del Z. Is it clear, guys, up to this? Yes. Now we are going to open these two brackets. So how do we open the brackets? How do we open the brackets when the terms are being multiplied? It's very easy. For opening the brackets in such cases, yes, we have to multiply. We have to multiply each and every term in one bracket with each and every term in the other bracket, like this. This A should be multiplied with B, and this A should be multiplied with del B also. And this del A should be multiplied with B, and this del A should be multiplied with del B also. Yes. So we can say A into B is equal to AB. Again, plus or minus A into del B. Is it clear? Now I am going to multiply by del A. So plus or minus del A into B, plus or minus del A into plus or minus del B, isn't it? Yes. So here instead of writing like this, we can write plus or minus del A into plus or minus del B. We can write like this, plus or minus del A into del B. This is how we open the brackets. This is how we open the brackets when the terms are, when we are multiplying the terms. Yes. If suppose it is like this, Z minus A. Yes. How do we find the sign? How do we find the sign of each term? How do we find the sign of each term when we are opening the bracket? Yes, while for finding the sign of each term, yes, here we have to apply the concept of negative numbers. If we are multiplying, if we are multiplying two positive numbers, the sign will be positive. If we are multiplying two negative numbers, again the sign will be positive. If we are multiplying one positive and negative, then the sign will be negative. Yes, you have to apply the concept. You have to apply the concept of negative numbers multiplication. Negative numbers multiplication for finding the sign of each term when you are opening the bracket. Is it clear? Yes. Now this del A and del B, So what is del A? Del A is nothing but the error in the measurement A. error in the measurement of physical quantity A, and del B is the error in the measurement of physical quantity B. Compared to A and B, we can say, compared to the actual measurement of A and B, we can say this del A and del B are extremely small, isn't it? Extremely small. Since these two values are extremely small, that is del A is extremely small and del B is again an extremely smaller value. So since we are multiplying these two extremely smaller values, suppose you are getting another value del C, let's assume you are getting another value del C, this del C will be even more smaller than del A and del B. So in this case what we are going to do is, we can say the product of del A and del B, or this particular term is negligible. This particular term is negligible. The value of this particular term is negligible compared to the whole value. The value of this particular term is very negligible compared to the whole value. Yes. So what we are going to do is, yes, we are going to eliminate this value. There is no need of, we are going to neglect this value. There is no need of considering this particular value. So our equation then becomes AB plus or minus A del plus or minus A del B plus del A B. Is it clear? Yes, we actually neglected, or we actually ignored this term. Why did we ignore this term? Yes, the value of this particular term has no effect on the whole value. Is it clear? Yes, has no effect, or we can say very little effect on the whole value. So we neglected. Yes. Now here we got the equation as, now the equation becomes z plus or minus del z is equal to AB plus or minus A del B and plus or minus B del A. Is it clear, guys? Yes. Now we know what is AB is equal to. AB is equal to Z. If we have same terms, if we have same values with same sign on both the sides of equation, yes, we can cancel those two terms. So thus we got is equal to A del B plus or minus B del A. A del B plus or minus B del Z. So not Z, del A. Okay. Now we are going to divide this equation. Now we are going to divide this equation by Z. We are going to divide this equation by Z, and we get the value as plus or minus del Z. Plus or minus del Z divided by Z. We know Z is equal to AB, isn't it? We know Z is equal to AB. So we can say dividing by Z is equal to dividing by AB, isn't it? Yes. So instead of dividing A del B and B del A by Z, here I am going to divide it by AB, because we know AB is not, Z is equal to, Z is nothing but that is AB. So these two A will get cancelled and these two B will get cancelled. Yes, these two A will get cancelled and these two B will get cancelled, and we will get, let me rub this. Okay, I am rubbing this and I am going to write here, we got the value as del Z by Z is equal to plus or minus del A by A plus or minus del B by B. Is it clear, guys? Plus or minus del Z by Z is equal to plus or minus del A by A plus or minus del B by B. Just like in the previous cases, just like in the previous two cases, here also we will have 4 different cases, isn't it? Here also we will have 4 different cases, and it is very clear that we will get to maximum error. We will get to the maximum error value when we are adding the individual errors, when we are adding the positive values of the individual errors, isn't it? Yes. So here it will be like this. So the maximum possible value of del Z by Z, the maximum possible value of del Z by Z is equal to, yes, the sum of Del z by z is equal to the sum of del a by a and del b by b. Yes. So what is del z by z? What is del z by z? Yes. And can anyone guess? What is del by z? Del z by z is nothing but the relative error, isn't it? What is relative error is equal to? Relative error is equal to error divided by actual value. Error divided by actual value, isn't it? Error divided by actual value. Del z is the error. Del z is the error in the resultant and z is the actual value. And del a is the error in the measurement of a, and a is the actual value. And for b also, del b is the error and b is the actual value. So actually here we are finding the relative errors of respective quantities. So we can say when we are multiplying two quantities, the relative error in the resultant quantity, is equal to the sum of relative errors of individual measurements. Is it clear, guys? Is it clear? Yes. So here if suppose you are asked to find the maximum possible error in the z value, so here you have to actually calculate what is del z is equal to. So what is del z is equal to? Del z is equal to z into del a by a plus del b by b. Is it clear? Yes. So if you are asked to find the relative error in the resultant, yes, it is enough to find up to this. If you are asked to find the maximum possible error, simply error in the resultant, yes, then you have to find what is del z is equal to using this equation. It is very easy. You have to simply multiply the value of a z with this with the sum of the relative errors in the individual measurements. Is it clear, guys? Yes. Let's discuss. Let's see once more. Let me explain it once more. Yes. And then we will move on to the next next case. Okay. Yes. So here the case is actually we are going to find how errors will get combined when we are multiplying two quantities. Here I have two quantities a and b, and I got the resultant. I get the resultant z when I multiply these two physical quantities. I measured the value of a and I got the value as a plus or minus with some error del a, and b plus or minus some error del b. Is it clear up to this? Yes. Here I know the value of z. Here I know the value of z is equal to, I have to find the product of these two measurements. Since I have errors in these two measurements, since there is some error in these two measurements, obviously there will be some error. There will be some error in the resultant also. So I wrote the resultant as z plus or minus del z. Now I am going to open the bracket. For opening the brackets when the terms are being multiplied, yes, we simply multiply each and every term in one bracket with each and every term in the other bracket. So I got the values as del b a plus del a del b. Yes, is it clear up to this? Yes. Now this I am going to eliminate. I am going to ignore this particular term. Why? Because the value of del a is extremely small, and del a is extremely small, and we can say del b is also extremely small. When we are multiplying two very smaller values, yes, the product will also be we can say the product will be even more smaller than these two values. So this particular value has no, we can say this particular term has no effect or very little effect on this value. So I am going to neglect this value. I am not going to consider this particular term. So now the equation becomes as follows: z plus del z is equal to del a b plus del BA. Is it clear? And here we know Z is equal to AB. So here we have some same values with same signs on both the sides of the equation. So they got cancelled. Now we got the equation as a del Z is equal to A del B plus B del A. Yes. Now I am going to divide the whole term by z. I am going to divide the whole term by z. Here I am going to replace z by ab. Replace z by ab because we know z is equal to ab. Z and ab are one and the same. So here I got the values as a del b divided by ab and b del a divided by ab. Here both the a get cancelled and here both the b get cancelled. So we will get del z by z. Del z by z is equal to del a by a plus del b by b. Is it clear, guys? Del z by z is nothing but the relative error in the resultant. What is relative error is equal to? Relative error is equal to error divided by actual value. Del z is the error in the resultant and z is the actual value of resultant. So del z by z is the relative error in the resultant and del a by a is the relative error in a and del b by b is the relative error in b. So we can conclude that. When we are multiplying two quantities, having some errors in their measurement, yes, the relative error in the resultant is equal to the maximum possible relative error in the resultant is equal to the sum of the relative errors of individual measurements. Is it clear, guys? Yes. If you are asked to find simply what is del z is equal to, then you have to multiply by z. Like this. Is it clear? Yes. So now let's see an example problem on multiplication and then we'll move on to the next one, that is division. Okay. Yes. Yes. If suppose here you are asked to find the distance. Here you are asked to find the distance travelled by some person A. Okay. Here you are asked to find the distance travelled by some person A and using the given values and you are given the values of speed and time. Here in this example you are asked to find the distance travelled by a man, namely A. Okay. Using the values given. And you are given the values of speed. Speed is equal to, speed of the vehicle is equal to 29 meter per second plus or minus 0.96 meter per second. And again you are given the value of time, that is equal to 30 seconds plus or minus 0.54 second. 30 seconds plus or minus 0.54 second. Is it clear? Here you want to find the maximum possible error. Here you want to find the maximum possible error in the distance. Let the distance be d. And here you want to find what is, you are asked to find the value of del d, maximum possible value of del d. Is it clear? Yes. So now let's find, we know del d by d, the relative error in the resultant is equal to the sum of the relative errors in individual measurements. So 0.96 divided by 29 plus 0.54 divided by 30 plus 0.54 divided by 30. So let's find the value. 0.96 divided by 29, 0.0331 plus 0.54 divided by 30 that is equal to 0.018. So we will get the value as 0.0331 plus 0.018. We get the value as 0.0511. So the relative error of the resultant D or the resultant distance is equal to 0.0511. But in this question you are asked to find not the relative error in the distance, but the error in the distance. You are asked to find not the relative error in the distance, but the error in the distance. So here you have to find the value of del D. So what is del D is equal to? We know del D is equal to D into this particular value. D into the value in the brackets, isn't it? So we can say D into 0.0511. D into 0.0511. So what is this D is equal to? How do you calculate the value of D? What is D? D is the actual distance. D is the actual distance. So what is distance equal to? Distance is equal to speed into time. So we can say actual distance is equal to actual speed into actual time, isn't it? We can say actual distance is equal to actual speed into actual time. So what is the value of actual speed? It is given 29 meter per second. So 29 meter per second into what is the value of actual time? It is given as 30 seconds. So 30 seconds. Is it clear? Yes. So now we will find the value 29 into 3. So 30 into 3 will be 900. 900 minus 3. We will get 897, I guess. Let me check. 29 into 3. Not 897. Sorry, 87. 870. Not 897. Sorry. 870. 870 meter. Yes, 29 meter per second into 30 is equal to 870 meters. Thus we got the value of D. So here we have to substitute the value of D. So del D is equal to 870 into 0.0511. 0.0511. So and that is equal to 870 into 0.0511. So that is equal to 44 divided by 457. 44 divided by 457. Is it clear, guys? How to find the relative error? How to find the relative error in the resultant, and how to find the value, or how to find the error in the resultant when we are finding or when we are multiplying two physical quantities. Is it clear? Yes. The actual speed, let's discuss one more problem. The actual speed of a bike, no, a man traveled from A to B. A man traveled from A to B in a bike. The speed of the bike actually it was some 30 meter per, not 30, let it be 50 meter per second. It was 50 meter per second. When measured the speed using a meter, it showed 49.5 meter per second. 49.5 meter per second. Okay. The time taken for reaching B from A was actually we can say 390 seconds. Okay, 390 seconds. When measured the time using a stopwatch, got the value as 392 seconds. 392 seconds. So, what is the maximum possible error in the distance? What is the maximum possible error in the distance? So we can say this problem is a verbal problem, isn't it? Yes. So now first let's try to understand the problem, then we will see the solution. How to solve this problem? A man traveled from A to B. In a bike. So he traveled from A to B in a bike. The actual speed of the bike was, the value of the actual speed is given as 50 meter per second. And the measured value of the speed is given as 49.5 seconds. So this is the actual speed and this is the measured value. Again, the time taken for reaching B from A, the actual time is given as 390 seconds. And when measured using a stopwatch, we got the value as 392 seconds. Isn't it? 390 seconds and 392 seconds. This is the actual value of a speed. Let it be SA. This is SA and this is SM, measured value. This is TA and this is TM. Here you have to find, here you are asked to find the maximum possible error in D. Okay, so we have to find what is del D is equal to. What is del D is equal to? We know distance. Now let's see how to solve this problem. We know distance is equal to speed into time. Distance is equal to speed into time. Yes. So here actually we are multiplying two physical quantities. Actually we are multiplying these two physical quantities having some error in their measurements. So we have to find the maximum possible error. We have to find the maximum possible error in the distance. So how do we find? We know del D by D is equal to del S by S. What is S here? In this case, S is equal to speed, del T by T. What is del S? Del is nothing but the error in the measurement. The actual value is given as 50 and the measured value is given as 49.5. Measured value is given as 49.5. So what is the error in the measurement? 0.5. Error in the measurement is 0.5. Now, what is the actual value? Actual value is 50. Is it clear? Now we have to add the relative error of time also. Relative error of time means the error in the measurement of time is nothing but 2 divided by actual value is 390 seconds. 2 seconds you have to, while doing problems, yes, you have to remember one point. You have to consider both values and units. If the units and if the given units are different, yes, then you have to, if the given units are different, then you have to make those units same. Okay, yes. Now we have to add up these two values. Let me add. Okay. .5 divided by 50 got the value as 0.01. 2 divided by 390 and we will get the value as 0.0051. Get the value as 0.0051. So 0.01 plus 0.0051, that is equal to 0.0151, 0.0151. Is it clear, guys? Now we got the value of relative error in the distance. Here we have to find not the relative error but the value of del D. How do we calculate the value of del D? Del D is equal to D into the sum of the relative errors in individual measurements. So what is the sum of the relative error in individual measurement? That is equal to 0. Let me write here. Del D is equal to 0.0151, isn't it? Yes, into D. So what is the value of D? D is nothing but the actual distance. So actual distance is equal to 50 into 390. 50 into 390. So what is del D is equal to 50 into 390 into 0.0151. Once you multiply all these values, once you multiply or find the product of these values, you will get what is the actual error or maximum possible error in the resultant distance. Is it clear, guys? Yes. Okay. Okay.